The last question is several parts, and it gives us a table. The first part is asking us to prove that h of x equals 0 on the interval 2 to 4. And looking at the graph, or at the table, sorry, we see that h of 2 is 1 and h of 4 is -3. So we could say that since the function is continuous and differentiable and f of 2 is greater than 0 and and 0 is greater than f of 4, then h of x equals 0 at some point on the closed interval 2 to 4 by intermediate value theorem. Part B is asking us to classify the only critical point shown on the table. And looking at the table, we could see that we're going from -3 to -7, so we're decreasing. And then we increase actually to -5 after h of 6. So we could say that the only critical point would be h of 6 equals -7. That should be b instead of by, because that is the only point where the slope changes out of all three graphs. C is asking us to determine if h has a point of inflection on one of the given subintervals. So we know that points of inflection are based off of the second derivative. We could say that h has a point of inflection between x equals 2 and x equals 4. We know this because the second derivative changes direction right here from negative to positive. So the graph would change from concave down to concave up. And then D is asking, must it be true that h prime of x equals -4/7 for some x value between x equals 2 and x equals 9? And again, looking at our table, we could see that between 2 and 4 even, it will equal -4/7. So we could say that since h prime of x is continuous and differentiable on the interval, and h prime of 2, which is -1, is less than -4/7, and that is less than h prime of 4, then h prime of x would equal -4/7 at some point on the interval, the closed interval 2 to 9 by intermediate value theorem.